Did you know that there are 5 common types of polar equations, and the key to graphing a polar equation is to recognize which type it is? Keep watching to find out more about this and to learn how to graph polar equations by walking through 4 example problems with me. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes where you can fill out the answers to the examples that we're going to do, because you can't just watch someone do math, you need to do it too. Before we dive into our example problems, let's go over the 5 common types of polar equations. The first type that we'll look at is the circle. If the circle is centered at the origin, the equation is r is equal to a, and the radius is equal to a. If the circle lies above the polar axis, the equation is r is equal to a sine theta, and the radius is equal to a divided by 2. As theta goes from 0 to pi, a sine theta goes from 0 to a and back to 0. If the circle lies on the right half of the polar axis, the equation is r is equal to a cosine theta, and the radius is again equal to a over 2. As theta goes from 0 to pi over 2, a cosine theta goes from a to 0, and then when theta goes from pi over 2 to pi, a cosine theta goes from 0 to minus a, which flips it in the opposite direction and completes the bottom half of the circle. The second type of polar equation that we'll look at is the spiral. The equation for a spiral is r is equal to a times theta. When theta is equal to 0, r is 0, so we begin at the pole. As theta increases, r also increases, and the graph spirals outward. The third type of polar equation is the limacon. This is also called the limacon of Pascal, and the name limacon comes from the Latin word for snail. There are 4 equations for a limacon. R is equal to a plus b sine theta, where the curve is primarily above the polar axis. R is equal to a minus b sine theta, where the curve is primarily below the polar axis. I didn't draw this one, but it's very similar to the one up above. R is equal to a plus b cosine theta, where the curve is primarily on the right half of the polar axis. And then lastly, R is equal to a minus b cosine theta, where the curve is primarily on the left half of the polar axis and is similar to the curve right above it. When a is less than b, there is an inner loop. When a is equal to b, the curve resembles a heart and is called a cardioid. And lastly, when a is greater than b, the curve resembles an apple. The fourth type of polar equation is the rose, and this one is probably the hardest one to graph. The equations for a rose are r is equal to a sine n theta, and r is equal to a cosine n theta. N is an integer equal to 2 or more. When n is even, the number of petals are doubled. For example, when n is 2, there are 4 petals. When n is odd, there are the same number of petals. For example, when n is equal to 3, there are 3 petals in the rose. Sine theta reaches a maximum value when theta is equal to pi over 2. Sine 2 theta will then reach its maximum value when 2 theta is equal to pi over 2, or theta is equal to pi over 4. So our maximum occurs at this point. Likewise, for the curve r is equal to sine 3 theta, the maximum will occur where 3 theta is equal to pi over 2, or theta is equal to pi over 6. This is where the maximum is for a 3-petal rose. For a rose governed by the equation r is equal to a cosine n theta, we know that cosine theta reaches a max when theta is equal to 0. So r is equal to cosine 2 theta and r is equal to cosine 3 theta both reach their max at 0. That occurs at this point and at this point. So when theta is equal to 0, r is equal to 1. The last type of polar equation that we'll look at is the lemniscate. There are 2 equations for a lemniscate, and the lemniscate looks like an infinity sign. For r squared is equal to sine 2 theta, sine 2 theta reaches the max at pi over 4, just like it did with the rose, and our max is at this point. For our cosine curve, it reaches its max at 0, and that is at this point, which is the point 1, 0. We'll now walk through 4 example problems of graphing a polar equation. To graph a polar equation, we first need to identify the polar equation. We can look and find out if it's a circle, a spiral, a limacon, a rose, or a lemniscate. We then need to create a table of values of r and theta, and then we can sketch the curve. The first example that we'll walk through is to sketch the graph of r is equal to 2 sine theta. This equation looks like r is equal to a sine theta, so we know that it's going to be a circle above the polar axis. Let's now create a table of values of r and theta. When we were studying the circle r is equal to a sine theta, we saw that a circle is traced out as we go from 0 to pi. So let's let theta take on values between 0 and pi. I'm going to start at 0 and end at pi. In the middle is pi over 2, and then here we have pi over 4, and here we have 3 pi over 4. We'll then compute our value of r. We're looking at the equation right up here. When theta is 0, sine is 0, so r is 0. Sine of pi over 4 is root 2 over 2, so this is root 2. Sine of pi over 2 is 1, so we have a 2. Sine of 3 pi over 4 is root 2 over 2 again, and we multiply that by 2, so we have a root 2. And then sine of pi is 0, so we come back down to 0. Let's remind ourselves that root 2 is approximately 1.4. We can now sketch the curve. Our values in our table above range from 0 to 1.4, so let's make this a 1, a 2, and a 3. When theta is 0, r is 0. When theta is pi over 4, r is 1.4. When theta is pi over 2, we go up to 2. Then we come back down to 1.4 and then back down to 0. So our circle looks like that. Our second example is to sketch the graph of r is equal to 2 theta. This equation looks like r is equal to a theta, so we know it's going to be a spiral. Let's let theta go from 0 to pi, and we'll see if that's enough values to sketch the curve. Theta starts at 0, ends at pi. We have pi over 2, pi over 4, and 3 pi over 4. Looking at this equation right here, when theta is 0, r is 0. And then we have 2 times pi over 4 gives us pi over 2. Then we have pi, 3 pi over 2, and lastly 2 times pi, which is 2 pi. Pi over 2 is approximately 1.6. Pi is approximately 3.1. 3 pi over 2 is 4.7. And then 2 pi is approximately 6.3. Let's now sketch the curve. Our values go from about 0 to 6. So let's let our first circle be 2 and then we'll go 4, and then we'll go up to 6. When theta is 0, r is 0. When theta is pi over 4, we're at 1.6. When theta is pi over 2, we're up to 3. When theta is 3 pi over 4, we're up to 4.7. And then when theta is equal to pi, we're up to 6.3. Let's now trace our curve. Which looks like a spiral. Our third equation is r is equal to 1 plus 2 cosine theta. This equation looks like r is equal to a plus b cosine theta, which is a limacon. We have a is equal to 1, b is equal to 2, so that tells us a is less than b, and we know that it's going to be a limacon with an inner loop, primarily on the right half plane. A limacon is similar to a circle and can be traced out as we go from 0 to pi. So let's let theta equal 0 up to pi. Since a limacon is more complicated, especially because this one has an inner loop, we'll include more values of theta. We'll start at 0, end at pi. In the middle, we have pi over 2. And then let's put the values that we know the value of cosine for. Let's put pi over 6, pi over 4, pi over 3. And then we have 2 pi over 3, 3 pi over 4, and lastly 5 pi over 6. Let's now plug in our r values. We're looking back up at this equation. When theta is 0, cosine of 0 is 1, so this is 3. Cosine of pi over 6 is root 3 over 2, so this becomes 1 plus root 3. See if we can squish it in. Cosine of pi over 4 is root 2 over 2, so this becomes 1 plus root 2. And then we do the same thing for the rest of the values, and we get 2, 1, 0, 1 minus root 2, 1 minus root 3, and lastly, minus 1. 1 plus root 3 is about 2.7. 1 plus root 2 is approximately 2.4. 1 minus root 2 is minus 0.4. And lastly, 1 minus root 3 is minus 0.7. Great. Now we get to sketch the curve. Our values of r go from 0 to 3. So let's let this be 1, 2, 3. When theta is equal to 0, r is equal to 3. At pi over 6, we have 2.7. At pi over 4, we have 2.4. And then at pi over 3, we have 2. At pi over 2, we have 1. At 2 pi over 3, we're back to 0. So let's go ahead and let's put in that part of the curve right there. So we know we're going from that point to that point. At 3 pi over 4, which is here, we go to minus 0.4, so it's in the opposite direction. Then at 5 pi over 6, we have minus 0.7. And then at pi, we have minus 1. Let's trace out this part of the curve. So you can see that we've drawn half of the curve. And we can see from this graph what the other half will look like, and we'll go ahead and put that in. If you're finding this video helpful, please give it a thumbs up and consider subscribing to my channel. Hang with me. We have one more example to do, and it's a really important one. Our last equation is r is equal to 3 times sine of 2 theta. This equation looks like r is equal to a sine n theta. So we know it's going to be a rose. N is equal to 2. So we know our rose is going to have 4 petals because we have to double the n because it's an even number. We know that our petal is going to reach a maximum at pi over 4, so we can trace out one petal from 0 to pi over 2. Let's let theta go from 0 to pi so we can trace out 2 petals. Theta starts at 0, goes to pi, and then in between it takes on the value pi over 4, pi over 2, and then 3 pi over 4. We're looking at this equation right up here. When theta is 0, sine is 0, so it starts at 0. Sine of 2 times pi over 4 is equal to 1, so we have a 3. Sine of pi is 0, so we're back down to 0. Sine of 3 pi over 2 is minus 1, so we get a minus 3. And then we're back to 0. I know that's not a lot of values, but it's really going to be enough to graph it since we know that it already is going to look like a rose. Our values go from 0 to 3, so let's let our first circle be 1, and then 2, and then 3. When theta is 0, r is 0. When theta is pi over 4, we're up to 3. Then we come back down to 0. So let's go ahead and trace this out. We're going to go up to 3, back down to 0. Then at 3 pi over 4, which is here, our value is going to be minus 3. So that point will be here. And then we'll go back to 0. So we'd get our second petal. If we continue on, our third petal looks like this. And then our fourth petal looks like that. I hope that you now feel more comfortable sketching polar equations and can work some examples on your own. In the next video, I'll teach you all that you need to know about plane curves and parametric equations.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.